Okay, we will go through the exemplar problems in the chapter 3, class 12 physics chapter 3, current electricity. Okay, before going through it I will show you some information from the book. So when we connect two resistors in parallel, okay, the equivalent resistance will be 1 by R1 plus 1 by R2. 1 by R equivalent equal to 1 by R1 plus 1 by R2. Okay. So R equivalent will be R1 R2 by R1 plus R2 it will come. When we connect in series, we have to just add this equivalent is R1 plus R2. Okay. Now when a current is passing through a resistor like this and this node, the current will be divided into these branches like this. So this I1 equal to I2 plus I3. Okay. The resistance is proportional to the resistivity and the length of the conductor and inversely proportional to the area of cross section. Okay, R is the resistance, this is the resistivity, length of the conductor, area of cross section. The resistivity will be same even after stretching. Okay, whatever be the resistivity of this material will be same. Okay, the mobility equal to Vd, drift velocity, divided by the electric field. Okay, the resistivity of metal increases with the increase in temperature. Okay, the resistivity rho of the metals will increase with the increase in temperature. Okay, the voltmeter, ideal voltmeter will act as a open circuit. Okay, infinite resistance means like a open voltmeter, but ammeter will act like a short circuit, that is the low resistance, zero resistance. Okay, the B.B. Roy of Great Britain, this used to identify the color codes given in your book. Brown, black, blue, brown, you can refer to the book. Okay, in the color codes, resistance color codes. Conductivity is inversely proportional to the resistivity. Okay, conductivity equal to 1 by resistivity. Okay, this is how the resistivity related to the temperature. Okay, the resistivity at the reference temperature, this rho 0, this is rho T is the resistivity at the given temperature. This is the temperature coefficient of resistivity T naught, the reference temperature and this given temperature. Okay, resistant at a final temperature is called resistant at the initial temperature. 1 plus alpha T. Alpha is the temperature coefficient. Okay, volume of any given wire, volume equal to length into area of cross section. Okay, volume remains constant even after recasting. Okay, the volume will be remains constant even after recasting. Power equal to V square by R. So V square by R can be written V, two V's we can write. V by R is I, so equal to Vi. So this V equal to IR, if you put then is I square. So we can write the power in various forms like this. V square by I, Vi, I square R. Okay. Resistivity formula. N is the number of free electrons per unit volume. T is the time between average time between the collisions. When you connect some few resistance in series, then the equivalent resistance, that is the resultant resistance, will always be greater than the maximum resistance connected in series. Okay, R max. R resultant is greater than the R max. When you connect in parallel, then R resultant is less than the R minimum. Okay, when you connect in series, R resultant is greater than the R max. In parallel, R resultant is less than the R minimum. Okay. Current density J equal to current per unit area I by A. When you connect two voltage sources and batteries in series like this in opposite way, that is negative is connected, so if you connect, the resultant voltage will be 6 minus 4, okay, 2 volts. But if you connect like this, positive negative in series, so the resultant voltage will be 10 volts, okay. So here we are assume that the battery's internal resistance is 0. Consider a current carrying wire of length L, shape of a circle. Okay. Note that as the current progresses along the wire, the direction of the current's density, that is current per unit area, changes in an exact manner, while the current remains unaffected. Current will be same, but current density changes depending on the wire bending or not. Okay, the agent that essentially responsible for this is current density. Okay, this is the electric field produced by charges accumulated on the surface of the wire. Source of the this is not the correct answer. Okay, the charges are not this. So this is the correct answer. Okay, electric field produced by charges accumulated on the surface of the wire. Current is same, but the current density changes. Two batteries and internal resistance are connected in parallel as shown here. Okay, the equivalent EMF of the two cells between E and D is okay. This is 23. Okay, this is the equivalent EMF. Okay, so that is in between these two EMFs. A resistance are to be measured using the meter gauge. Student chooses the standard resistance as 100 ohms. You find the null at this centimeter, totally 100 centimeter at 2.9 centimeter is null point is coming. So he is told to attempt to improve the accuracy. Okay, for better accuracy, the null point should be close to this middle. That is when you have a meter scale, that is 100 centimeter, the null point should be around 50 centimeter. Okay, then only it will be more accuracy. Okay, so the 2.9 cm is around 3 ohms. So because there are 100 centimeters are there in 1 meter. Okay, the 100 division. So the 100 ohm means 100 divided by 100, around 1 ohm per centimeter approximately. So 2.9 around 3 ohms per 3 centimeter. Actually, so for better accuracy, R by S should be around 1. So he has to replace with the 3 ohm resistance. Should be 3 ohm resistance, then only it will be more accurate. Okay. For better accuracy, this R by S should be nearly 1. Okay, when you found the resistance as 3 ohm, then standard resistance is also at 3 ohm, means then it will be a better accuracy. This R by S should be around 1. So that means it is around middle of this scale. Two cells of EMF also are accurately compared using the potentiometer of length 400 centimeter. The battery that runs the potentiometer should have the also no. Actually, the potential difference in the wire should be slightly more than the measured EMF of the cell. So adjust R for this. So if you comparing these two voltages, the 10 volts means the potential drop across the potentiometer wire should be slightly more than 10 volts. So we have to adjust the variable resistance for this. So the battery of the potentiometer can have 15 volts. R should be adjusted so the potential difference across the wire slightly exists. So this is the correct answer. Okay. Okay, here. So you have to adjust here so that the potential difference across this N1 from A to N1 should be slightly higher than the measured EMF. Okay, here I mentioned this. Here metal rod of length 10 cm rectangle area okay is given. The resistance will be R equal to length divided by the area of cross section. So it will be maximum the maximum when the cross section is minimum. Okay, when A is minimum then this R will be maximum. So this is based on that and this is the correct answer. So here the area is more, so the resistance will not be maximum. Here also area is more, this is the least area. Which of the following characteristics electron determine the current in the conductor? Drift due to the drift velocity alone. This determines the current in the conductor. Okay, this is the drift. Electron move the rate velocity and the electrons are greater the phenomena of the drift velocity. So you can go through what is drift velocity, how the electric field affects this drift velocity. Kirchhoff's junction rule is the reflection of the conservation of charges. Okay, conservation of the current density, no. In fact, that momentum, no. This is not the fact that there is a accumulation of charges. Okay, this is also correct. Okay, 24. Kirchhoff's rule. Okay, this is the rule. We can go through this rule. Okay, this is the current rule and junction rule. Okay, consider the simple circuit here. Stand for the variable resistance. Voltage can vary R to infinity. Okay. Potential drop across AB is nearly constant. Yes, when you vary the current changes, but the potential across AB will remain constant. Current through the R is nearly constant. No, and this is not constant. Varied means current changes. Current I depends on sensitivity. Okay, I equal to V by this R, that is internal resistance. Okay. Current varies based on the variable resistance, so voltage remains constant. Current varies, okay, voltage remains constant. Temperature dependence of the resistivity of semiconductor insulators and metals is significantly based on the following factors. 11 and 12. Okay, the number of charge carriers change with the temperature. Time interval between the two successive collisions, that is the relaxation period, depends on the temperature. Okay, 11, 12. Okay, there is a formula here, and there is also one more formula here. Okay, you can go through it so you understand it. The measurement of unknown resistance are to be measured with the Wheatstone bridge. Okay, in the book, two students perform the experiments in two ways. First, R1 this 5 ohm, 100 ohm 5 ohm, the other okay, in the standard ratio. The error of the measurements of these two students are the same. No, that is not same. Error of the measurement depends on the accuracy which yes, this accuracy with which is chosen. If the student uses large values of this resistance, current through them will be feeble, that is less. This will make the determination more difficult. As these two are the correct. 27. Okay. Okay, so we have to choose this so that we can get sufficient current here. More resistance means very less current, and will be determining the resistance will be difficult. This is unknown resistance, and this is the standard arm. Okay, question number 11. A meter bridge point D is the neutral point. Okay, neutral point. Neutral point means point B and D are at the same potential. Okay, neutral point. The meter bridge can have no other neutral point. Okay, for the same set of R and S. Okay, that is correct. When jockey conductor the position, the meter wire left of D current flows. No, on the right of D only the current flows. This one. When R is increased, the neutral point shift to the left. No, that is not true. Okay. Now book page. So you can go through how the meter bridge works in this. The rates of the neutral point potential, if you move this jockey, right, the potential difference across this increases, so that the potential at D will decrease. So now the potential at B will be greater than the potential at D, then current will flow. Okay. AD increases, so the potential at D will be less than the potential at B, so the current flows. Okay. Is the momentum conserved when charge crosses a junction in the electric circuit? Why I will not show the answer. When the electron approaches junction, in addition to the uniform electric field, that is normally phases which keep the drift velocity fixed, there are accumulated charges on the surface of the wire at the junction. These produce electric field. These fields alter the direction of the momentum. Okay. The relaxation time is nearly independent of the applied electric field. whereas it changes significantly with the temperature T. First effect is what is responsible for the Ohm's law, whereas second the variation of resistivity with the temperature. Love it. Relaxation time is bound to depend on velocities of electrons and ions. Relaxation time, okay. Applied electric field affects the velocities of the electrons by speeds to the order of 1 mm per second. Okay, applied electric field affect this velocity of it is insignificant. Change in the temperature on the other hand affects this much. Okay, so the change in temperature affects the velocity of the electrons much more than the due to the electric field. Okay, this can affect it significantly. Okay, which is dependence is ignorable for ordinary applied voltages. What are the advantages of the null point method in the Wheatstone bridge? When the additional measurement would be required, calculate the or unknown by any other method. 14. The advantage of a null point method is that the resistance of the galvanometer does not affect the balance point. Okay, the resistance of the galvanometer does not affect the balance point. So, okay, no need to determine the current and resistance and the galvanometer and the internal resistance of the galvanometer or unknown can be calculated applying Kirchhoff's rules on this circuit. Okay, we would need additional accurate measurements of all current and the resistance of the galvanometer current resistance. What is the advantage of using thick metallic strips? Metallic strip to join wires in the potentiometer. 15. Metallic strips have the low resistance and need not be counted in the potentiometer length. Okay, metal is a low resistance, so it need not be counted in the potentiometer length. Okay, one measures only these length along the straight segments of the length. Okay, this is regularly done with the help of the centimeter rulings on the meter. For wiring in Ohm, one uses copper wires or aluminum. What consideration is involved in it? Two consideration: one, cost of the metal, then conductivity of the metal. Cost factor, with silver is more costly than these two. So copper and aluminum are the next best conductors. Why are alloys used in making the standard resistance coils? Alloys have the low value of temperature coefficient. Okay, less temperature sensitivity of resistance and high resistivity. Power P is delivered to the device in the transmission cables having the resistance. This is resistance transmission cable. V is the voltage across R and I is the current. To find the power wasted and how it can be reduced. Okay, power wasted is this resistance of the conducting wire into the power. Okay, so based on this formula, the voltage is coming in the denominator. So if we increase the voltage, the power this power PC power loss will be minimum. So in order to reduce the power loss, power should be transmitted at the high voltage. AB is a potentiometer wire. If the value of the R is increased, in which direction the balance point will J will shift. When you actually R increases, the current will decrease. So voltage drop, voltage gradient will come down. So we have to shift this to the right side. 3.19. If R increase, current through the wire will decrease, and hence the potential gradients also will decrease, which will result in the increase in balance length. So J will shift on the towards B to increase the balance length. Current decreases, so we have to increase the balance length for the same potential. So it will shift on the right side. While do an experiment with potentiometer, it was found that the reduction is one-sided, the deflection is decreased from okay. In the first case, which terminal positive or negative of the cell is connected to the X? And this side more means here positive should be connected. This side more means this side positive should be connected. Okay. So now answer. Positive terminal of V is connected, okay, when the left side is more. Negative terminal is connected when the right side is more, okay. This side is second case. The deflection is increased while the jog is moved towards this side. So here deflection more means this side you have to connect positive. This side more means this side positive. A cell of EMF V and relation R is connected in across the external resistance R. Plot the graph showing the variation of the potential across R. The potential keep on increasing at some point. It's equal to the potential of this, then it will be steady. Okay, potential when it is equal to this potential, then it will be steady. It will not increase. Find the set of any equal resistance or each connected in series of the battery. Current is observed to flow. Then the N connector is parallel the same battery. It is observed the current is increased 10 times. Okay. 3.22. And connected in series, the total resistance is NR. Same resistance R is connected in series, N resistance. And connected in parallel, then N by R. R equal to R by N. Okay, 1 by R equal to N by R. So R equal to R by N. Okay. So now parallel the voltage will remain same. Current. Okay. That voltage equal to current into resistance V equal to IR. So this is the series case and this is the parallel case. When you solve this equation, we get N equal to 10. Okay, here also. Okay, let there be N resistance. Okay, this thing. So they basically when we connect resistance in series, R resultant is greater than the R maximum. When in parallel, R resultant is less than the R minimum. It is 23. Okay, you can go through this answer. R resultant is when you connected in series, R resultant greater than the R maximum. Parallel means R resultant less than the R minimum. The circuit 3 shows two cells connected in opposition. Okay, here connecting the negative parallel E1 with the EMF 6 volt 2 ohm internal resistance 4 volt 8 ohm. Find the potential difference. Okay. This is the circuit. So we have internal resistance of 2 ohm here, 8 ohm here. Because these are connected up in opposite way, the resultant voltage will be this voltage minus this voltage. So 2 volt. 2 volt divided by the total resistance, so 0.2 ohm. This is the direction of current they are given. Current flows in this direction. The PD across E1. So the current flows in this direction. The potential drop in the direction of the current means you have to use the negative. Okay, here also from this battery current flows this, so this is the direction of the current. Internal resistance is 2 ohm, so you use on the direction of the current, use negative sign for the voltage drop in the direction of the current. Here current flows from here to this, so this is the potential. Here E2, see here for this battery current will flow here, but current direction is given, so this is opposite to the current direction. Here voltage drop. Okay, then you have to add this. Current flows from the positive to negative. Okay, here for this battery, this voltage drop in the internal direction is opposite. You have to add opposite the current direction. You have to add. So 4 plus 0. Okay, so this is potential difference across this. The potential here is more than the potentiality here. Two cells of the same E, but internal resistance are connected in series and the external resistance are. What should be the value of their? Okay, so answer 3.25. Same battery. This is the resistance and these are internal resistance. This is I. Okay. So now you can go through these things. Two conductors are made up of same material and hence the same length. Conductor A is a solid wire of diameter of conductor B. Okay. Find the ratio of these things. 3.26. So you can go through the answer here. This is the outer radius minus inner radius they are giving to find the thickness. Suppose that there is a circuit consisting of only resistances and batteries, and we have to double for increase to the n times. Okay, all voltage and resistance, so that the currents are unaltered. Do this for okay. We can think. Okay, you can go through the answer here. Two cells of the voltage 10 volts and 2 volts. Okay, 10 volt 2 volts and internal resistance 10 ohm and 5 ohm. Okay, connected in parallel with the positive end of the 10 volt battery. 10 volt battery. Find the effective voltage and the effective resistance. So here you have to use the Kirchhoff's law. Okay, they are taken two loops, the outer loop here and this loop, inner loop. Okay, one loop, outer loop, one this loop. So here you can see how this current Kirchhoff's current law, Kirchhoff's loop rule is applied. Okay, junction rule and loop rule. So the outer loop. So This is the resultant effective voltage and resistance. A room has AC 5 hours a day voltage. Okay. The wiring of the room consists of copper and 1 mm radius. Okay. 3.29. Power consumption. Okay, you can go through this also. In an experiment with the potentiometer, so with this 10 volt R is adjusted to be 50 ohm. A student wanting to measure this EMF. So here again, so what you have to do is, I'll show you the answer. Okay, these are the condition how you choose the variable resistance. Okay, the thing is that basic thing is that this is chosen such that the potential drop this across this should be greater than the EMF we are going to measure. Consider the circuit, how much energy is absorbed by electrons from the initial no current, ignore. Okay, electrons go. Okay, these things show the answer 31. Okay, you can go through this answer. Okay.